Welcome to the third webinar sponsored by the new Workflow 4.0 e-newsletter and ClearEdge 3D. Our webinar topic today is 21 time-saving scanning and modeling tips for as-built MEP projects. Thanks for joining us. My name is Kevin Corbley and I'll be your moderator today. I'm the Editor-in-Chief of Workflow 4.0, the newsletter of 3D scanning, modeling, documentation, ideas, and opinions. Today's webinar is packed with scanning and modeling tips that are sure to make your next as-built MEP project progress smoothly and efficiently. Whether your project involves a hospital addition or a plant expansion, you'll leave today with ideas you can put into practice right away. And the goal of this webinar is to help you cut hours out of your workflow, both in the field while capturing your laser scans and back at the office during the 3D modeling. Our panel of experts brings almost 30 years of scanning and modeling experience with them today, and with their guidance, you'll cut costs and boost profits on your next MEP project. Let's take a quick look at today's agenda. We'll be hearing about new scanning techniques and modeling best practices from a panel of experts who have experienced every phase of creating 3D BIMs. We'll hear several anecdotes and examples of what has worked best in real-life MEP projects. And we've divided our tips into 4 groups, as you can see. We've got the bidding and project planning. Then we will have 7 on-site data collection tips, followed by 9 data processing and modeling tips. And we'll wrap it up with 2 general tips, ideas, best practices, and lessons learned. And as we always do, we'll finish up the webinar with about 10 minutes or so answering your questions from the audience. And a couple of quick housekeeping details before we get started. Everyone is muted during the session except for the presenters. Now, feel free to ask questions at any time using the question box, not the chat box during the session. The question box should be in your right-hand side of your screen. And we'll be taking those questions during the Q&A session at the end. And this webinar is being recorded, and you'll each receive a link afterwards so you can go back and see it again or send it to your colleagues. And please subscribe to Workflow 4.0. That's the e-newsletter for learning as well as sharing experiences, opinions, and best practices. And there you can see the web address to subscribe and look at the most current issue, which just came out last week. All right, and let me take a minute to introduce the panelists. We've got Larry Kleinkemper, President of Landmar Services in Austin, Texas, and he's going to be providing his insights into scanning and modeling today. As you see, he started his company in 2008. He's an experienced architect and 3D modeling expert, and he has 20 years of project management experience. Larry, good to have you with us today.
Thanks, Kevin. It's good to be here.
All right, great. And also we've got Mike Paff, and he's the HDS manager at Bowman Consulting based in Chantilly, Virginia. And he has 6 years scanning experience, 12 years experience in surveying as well, along with a multitude of scanning projects and using different scanner types. And he is also currently in California a land surveyor in training. Mike, glad you could join us today.
Glad to be here, sir.
All right, great. And next up will be Mark Hanna. He is president or managing director, of Precision Point Incorporated in Indiana. And for those of you who read our last issue of Workflow 4.0, you may remember that we featured Mark in a recent project at the Elkhart General Hospital, which will be mentioned once or twice here today. Mark founded his company in 2009. He has a bachelor's degree in mechanical engineering as well as surveying, and he's got 6 years of scanning experience, and also he's got an award under his belt, one of the SBA 2012 Edge Awards for leadership excellence. Mark, good to have you with us as well.
Great to be here, Kevin.
And a familiar face to a lot of you who've joined us before is Kevin Williams. He's the chief scientist for ClearEdge 3D, and he's going to have several tips for us how to get the most out of Edgewise MEP. And he is actually the founder of ClearEdge 3D, started the company in 2007, an expert in automated feature extraction from point clouds, and He is the recipient of 2 National Science Foundation research grants. And Kevin, always a pleasure to have your expertise on the panel.
Thank you, Kevin.
All right, great. Well, as we like to say in our webinars, context is king. So let me set the stage for today's webinar by providing some context that I think will resonate with most of you. As-built MEP is often the most important and challenging part of any BIM project. And clients are more often demanding a Revit deliverable. And as a lot of you probably know, Revit struggles with as-built modeling. So understanding typical as-built MEP project challenges and proactively planning for them can be the difference maker in project success. And this webinar is all about arming you with the best tips, practices, lessons learned, things that you can apply in your next MEP project. All right, in terms of the agenda, as I said, we are going to start off with bidding and project planning tips. And I believe that's going to bring Mark Hanna. Mark, you there?
Yes, I'm here. Hi, Kevin.
Great.
Yeah, tip number 1 might seem obvious, but you know, trying to get a site visit is absolutely essential. In particular with MEP existing conditions, up in the ceiling plenum space, that's where all these pipes and some ancillary equipment are residing, and it's good to visit the site, determine can get access to the ceiling space, or what kind of tiles are there, or is it hard surface, and if you do have access, it's critical to open some ceiling tiles, determine how much space you have up there, because believe it or not, in some sites we've been to, there's not enough clearance, so there's just too much congestion in there. We can't even get a scanner to penetrate into that space. So it's absolutely essential that you visit the site. Other important areas would be to understand the area you're trying to get to. Do you have access to those maybe secure spaces in the building? We do a lot of hospitals, and naturally, some areas they don't want scanners running around in there during operational time. So we have to work with the staff and the facilities department to determine times to get into those critical spaces. So oftentimes our crews are working at night or weekends. So might seem obvious, but very important.
Mike, go ahead.
Yeah, with my experience on we've done some hospital work ourselves and commercial. We do some mining work out in Arizona area and New Mexico, and a lot of times we are completely constrained on when we can access an area. And the more communication that you put forth in working with the site people and ultimately the client, better off you'll be. I know one of the bigger complaints that we have had from taking over sites is that there just wasn't communication there for them, and maybe even mapping out where you're going to be, how long you'll be there. A lot of these site managers really like that kind of forward thinking in project planning and management, so they know where you're going to be, how long you'll be there, when you'll be out, and it makes you look good.
Okay. Mark, that brings you back on.
Yeah, another one we always like to ask for would be getting our hands on some existing as-built drawings if they exist. We, of course, are relying on the scan data to determine as-is conditions, but there's still a lot of good information in there. For instance, oftentimes when we're scanning for MEP, we don't know the size of the pipe because it's hidden behind insulation. So the record drawings help us determine what nominal size pipe is supposed to be there. Furthermore, it helps with verifying pipe types and mechanical systems, and this really comes down to the modeling side and the processing side. But it's good to have those with you for when you tackle projects such as these.
Okay.
Scope creep. I think we're all familiar with how that works. We've kind of been able to circumvent some of these issues when we have our initial site meeting, that we go over in detail what is expected from the client as far as and the MEP folks on their side, and then what we're ultimately going to give them as a result, and bring up the specs and limits to pipe size, what we're going to actually model and what we're not. Doing that up front with a lot of the, if you can get everyone on site and kind of go over things, seems to do a lot as far as limiting the expectations. A lot of times you'd be working with a client and the architect will be the sub. That's a good place to be. You have the ability to kind of keep your client aware of what the architect has been asking from you as far as extras and additional work. I know that we do have to do some, it's kind of expected and professional courtesy to do a little bit more than less. Sometimes you do have to kind of enforce that to make sure that it's a profitable job.
Okay, and now we're going to move on to our tips on on-site data collection. Larry?
Yeah, so it's the 3D scanners that are out there are extremely accurate, but there's always the opportunity for it to come out of calibration, or through the process to add inaccuracies, introduce errors. So it's always best to have a second to third measuring device on site that's kind of gathering just sort of a double check on what the building is doing or what the site is doing. A total station is by far the best instrument to gain control. On small jobs, we've implemented using a disto, but the trick is, one, get to the longest dimension you possibly can, and then compare that to the 3D scanner, and also measuring between targets. So if you have a paper target on two walls that are at the far end of the building and you can reach it with the disto or some sort of electronic measuring device, that's a great second measurement that you can then go back and double check against your 3D scanner and see if there's an error or a discrepancy. And then at least at that point you know whether or not, if they're both agreeing, you know you're dead on. If they aren't, you got to find out which instrument is more accurate. Thanks.
Yeah, we also implement cloud-to-cloud registration, not necessarily for the registration, but it's a good way to do analysis of the overall fit of the clouds. I don't know if a lot of people are familiar with that, but it definitely will point fingers at rogue clouds or something that's going on locally in your environment if you have people to implement that.
Okay, great.
Tip number 6, we're often tasked with doing rather large projects, and in particular when you're scanning the MEP up in ceilings, it can get quite a bit overwhelming, especially for the scan crews and then the post-processing of the data and the registration down the field. So as both Mike and Larry have pointed out, it's absolutely essential that we use survey total stations with all our scanning projects to aid us in the post-registration process, as well as it really enables us to break a building down, for instance, into smaller chunks that are much more manageable. We found that it reduces potential for omitting areas, and also helps us in the scan registration where we can tie all those clusters together, floor to floor, for instance, and have high confidence that we've got good spatial data there that's as accurate as we can make it. So that's how we attack a large project.
As far as our experience, typically, if you are on site longer, it reduces a lot of moving equipment around, setup time, access time, especially in the evenings. If a lot of these projects we end up doing our evening sites, the longer you could be on site, the more profitable you'll end up being, especially with travel time. You know, there's traffic and that sort of stuff gets very costly, and it also gives you a cushion of time at the end of the process where you may have bought yourself an extra couple hours to go back and get missing data or QC some areas, or even, you know, get those extra pictures that mean a lot as far as going through and drafting.
Mark, you want to tell us about the elevated tripod technique at the Elkhart Hospital? Oh, did we lose Mark? All right, well, while he tries to get back on, we'll go to the next one. All right, Mike?
Stability of the equipment. We do a fair amount of rooftop work along with our MEP initial. A lot of times we'll be in New York doing high-rise work, and there happens to be a lot of vibration or just areas that you weren't prepared for to go up there with your tripod. You'll end up punching holes in the roof and causing leaks and various other things. So I guess the idea is to get the most stable and safe setup for your $100,000 scanner that you happen to have up there. We've had a few really close calls in museums where you have a lot of people passing by. If you can get something like I'm a real fan of the Moog tripod setup here because it's turns into one piece. You can kick a leg on it, and it is very stable as opposed to using the floor chucks, which a lot of people use. This makes it into a complete one-unit piece that is very hard to break down. We've had the unfortunate occurrence to have sent our scanner off because of some little kid ended up walking by there, and it took a hit, and it's, you know, that's gone for, it was gone for 3 months on us. So it was a wake-up call for us as far as getting things protected and in a way that people cannot influence it around you. And they also come up with these elevated tripod mechanisms there, like you see for getting up in plenum spaces. But I've been real happy with that particular one, and I hope people spend the extra money to protect their gear.
That makes sense. All right. And Mark, did you get back on?
Yeah, I'm back on. My apologies for that.
There we go. Do you want me to go back and go back to the tape? Because,
that'd be great, please.
Yeah. There we go. Tell us about this. Is pretty interesting. Go ahead.
Yeah, I think also to maybe expand on Mike's points, which are excellent, is you know, when you're scanning, in particular ceilings, when you're working 10 to 16 feet off the ground, get that scanner stabilized on a good tripod. We actually equip ours with casters and elevator tripods so that we can get the scanner up high, keep it secure on the tripod, so we're not removing it and carrying up ladders. And most importantly, it reduces time and ease of access into the ceiling plenum space, much less intrusive. We can remove less tiles, and then we operate the scanner wirelessly, so a guy is safe on the ground, and we can run the scanner remotely and even preview the scan images before we move it to determine if we maybe need to run that scan again. So this is a really helpful tool to save some time and money and also safety.
Yeah, great. And I think you used a Kindle Fire, is that right, on at least one of the projects to do the remote control?
Yeah, we use the Kindle Fire or any Android type phone device would work as well.
Is that through the Ferrell scanner that has that interface?
Yes, it does.
Okay, and then that brings us back to tip number 10, Mark.
Kind of expanding on that, when, for instance, maybe inside hospitals or factories, we often don't get a lot of time in there, the opportunity to spend a lot of time in there. So we like to run multiple scanners when we can. It's really convenient for running MEP. We'll use one scanner to just acquire targets and get maybe the architectural features, and then we run a second scanner on that elevated tripod I just showed. That we utilize up in the ceiling space. So it's we found a significant time savings doing it that way as well.
Yeah, I have to agree with Mark on that. That's definitely a workflow. If you can get your control, scan, and use the tool for what it's made for. That C10 is great for structural stuff, but it may not be as hot as it is for piping on like the Ferrell is. So I'm totally behind you on that method as far as being able to lower your costs of operations on the site and get your bids down.
Yeah, also, Mike, to expand on that a little more, going back to the earlier tips, having a good pre-plan in place is really essential when you're running multiple scanners, because you've got to manage that data when you bring it back to the office. So field and pre-planning, can't stress how important that is to have all that in place.
Oh, true.
Tip 11 sometimes is obvious, sometimes not. We have found when we're scanning up in ceilings, a lot of our clients think you move one tile, put the scanner up there, and hit the go button. Oftentimes that is not the case, although it would be nice. We're finding that we're scanning multiple positions. If we're in a room, for instance, we're scanning maybe 3 to 5 positions up in the ceilings, plenum space, to ensure that we're getting adequate coverage. Again, we're thinking about modeling down the road, and it's critical that we get good results when we're running tools like Edgewise, and this really helps with that.
Yeah, I'd like to make a comment on that too. That the lower the ceiling clearance is from the plenum, ultimately the more scans you're going to have to get to saturation in that area. So if they send someone out to get a estimate or something along those lines, it's if they know nothing else, have them check what the span is from the plenum up to the hard surface of the ceiling.
Okay. All right. And before we move into the next section, let me just remind the audience that you can go ahead and start sending your questions in using the question box, and we will get to those at the end. And just a quick note for the panel, Kevin Williams, I've lost my view of my dashboard, so if I can't get that back, I think you're going to have to lead the Q&A session, Kevin, if that's okay with you. And I'll see if I can change the view here on screen and get my dashboard back. But while I'm doing that, let's move into data processing and modeling tips. And that's going to bring us to Larry.
Yeah, so tip 12. Before even beginning to import scans or starting the model, I like to change all of my views to the existing phase. And what that does is it makes it easy for the people who are going to be designing new construction to either demo what's existing or to separate their stuff from ours. It also gives us an opportunity to easily hand them updates if it turns out there's something that didn't seem like it was important at the time, but then they need more information on it. So yeah, phase filters, they rock.
All right. Go ahead, Mark.
Another process that we do here that, internally, again, thinking about our ultimate end goal here, providing a good deliverable, we have found that we're running tools like Edgewise. when we clean the scan data up, run through filter routines to reduce stray points and artifacting on the pipes, removing dark points or unwanted scan points, we're really yielding much better results when we're running the auto extraction pipe tools. So this should be standard in a process, but I can't emphasize how important this is to, before you start modeling, clean that scan data up as best you can, running filters.
Okay. All right, Larry, that brings you back on.
Great. So tip 14, I know a lot of people want to bring those scans in and then rotate them so that, you know, the longest direction is sort of horizontal and it's somewhat planned north. It's best to actually use rotate project north. So under manage in the Revit pull down, you'll see position, and at position there's rotate project north. And then over on your properties for each view, you may or may not, it's typically set to project north once you do that, but you may have to double check that where I've circled over in the red to the right, and or to the left, sorry. And that will help you immensely downstream if you bring in any more scans later that you may have thought that you didn't need, or when working with a program like Edgewise, all of their pipes and objects will come in right into place if you haven't moved those scans and if you use this method. Okay.
Yeah, that's a great point Larry brings up, and I think it's essential as well that when you do a modeling, you preserve the scanner coordinates so that when you're adding more data, everything's coming in at the correct place in the Revit model. So leading to tip 15, if you're running tools like Edgewise, there's some very powerful tools within the software. One of them is called Easy Connect. There are shadows inherent in scan data as you're picking up and scanning pipes. There's a nice feature in there that will connect and complete the pipe runs where no scan data exists. We've discovered through using the tool that it's better.
Oop, did we lose Mark again?
Yeah, can you hear me still?
Yeah, we got you, Mark. Is that you?
Okay.
There you go.
Actually,
We lost you for a second. Yep.
So we've discovered that running this command, starting it incrementally and then increasing it, really ensures us a much higher confidence in the pipe connections. So we're yielding much better results. If you get too aggressive with this feature, we found it's modeling, completing runs that are not accurate to what was actually collected by the point cloud.
All right.
Furthermore, there's some other nice features. Oftentimes, we're collecting scan data in Grayscale mode, and we found that some nice features are the optimization of the opacity settings in Edgewise, and this is a really nice feature where it will interpolate the point intensity data to improve the visualization. As you can see in this screen capture, isolated points, maybe that are darker points, are captured a different color. This really helps with modeling fittings, ensuring that you're continuing to maintain high accuracy doing your modeling using this. So this is a great feature that we found very helpful.
Tip 17, once scans are imported and positioned correctly in Revit, pin them. This kind of locks them into place, and then never ever move those scans to fit your model. In fact, if you find an intern or some young modeler unpinning them to move the scans, you can give them one warning and then fire them. This is really important to keep those scans sort of locked in place.
All right, that does sound important. All right.
Tip 18 there is the clipping box. Oftentimes you'll get in these areas where there is a lot, or you have to chase a particular rundown. This example up here is showing that you can isolate a series of pipes vertically without having to go through the process of looking all the data at one time. We find that very, very useful in what we do. We use it quite a bit. Also, I want to mention there about, back on that last tip, as far as bringing in pipe models, you guys may want to look into using work sets to install your models. We found that when you bring in the piping, a lot of times the client will want it prior to its being through QC, just to have access to what's going on in there. If you in Revit utilize the work sets, that allows you to take out and put back in or replace entire model sections without having to go through and pick individual items out for deletion. Gives you a lot more control and also allows you to kind of unify your team as far as being able to have multiple work sets going as far as the MEP modeling goes.
Okay.
Similarly, we do clipping. Sometimes we'll do it though prior to getting it into Edgewise. We'll clip out, in particular for ceiling plenum spaces. This is really easy to do in the scanning software, where we can isolate the area inside of a ceiling plenum and remove points below the ceiling and above the ceiling. As you can see in this image, in the right side, we've got rid of most of the noise that we don't care about. Our objective here is just to extract and model pipes. So it really reduces a lot of those false positives. And it, furthermore, it enables softwares to run a lot faster because we're working with smaller scan file sizes as well.
Okay.
In Revit, we found with working with gigantic scan files that it is best to, under Insert, use the managed links and load and unload as needed, and really use that. You end up using that a lot. VV is okay for short overrides to quickly hide or turn off for just a couple commands and then turn scan back on. But you will greatly improve your performance if you use managed links and actually unload the files altogether so that the computer's not thinking about them.
Okay, and we're almost through. We're just come down to our final couple of tips and best practices, and we're going to move on. And one more reminder for the audience, go ahead, send us your questions, type them into the question window, and I'm going to try to get that window back. I can't see it right now, Kevin Williams, but I'm going to try to get it back by switching my view here, but let's just keep moving forward.
Right, so the biggest and the baddest isn't necessarily the best in computer hardware. Revit still only uses one core. Why? So anyways, make sure you're getting the highest gigahertz you can, and have it set to auto overclock. That'll, hopefully you'll get 3 to 4 gigahertz range, and that's great for helping out. RAM equals crashes. The less RAM you have, the more often you're going to crash. 24 gigabytes we found is absolute minimum for stability. If you have 8 gigs, you're likely going to crash when modeling with point clouds. 4 gigabytes of video RAM is what we're using. We feel like it's a pretty decent speed for as far as zooming, panning, and changing views and keeping our productivity up. And then almost all of us do have multi-cores. The one place where you can use it, and this is just for those of us who are in 2013 or prior, if you're still creating PCGs, little unknown fact, you can create multiple PCGs at one time. So what we have found is it's basically how many true cores you have. So if you've got a quad core that's 4 cores, you can create 3 to 4 PCGs at one time, send them off. If you've got a hex core, you've got 6 cores, so it's not the hyper-threaded cores. You don't get twice as many, but you will, on average, get 5 or 6 out of that one. You can send them at one time and have them working on it, and it reduces your time in that process.
I would like to add to that too. When you go and get the dedicated video card in your PCs or your laptops, make sure your IT guys go in there and assign the appropriate visual setting for that program you're using. By nature, they're just set at kind of a general use, general purpose setting. You have to actually go inside and assign the higher end graphics to a particular program for it to utilize that card to your advantage.
Okay, and that brings us to tip 22.
Yeah, tip 22, I think really kind of ties all this, everything together here. Unfortunately, for existing conditions, MEP Revit is not a great tool for doing that. So we're doing majority of our pipe modeling using tools like Edgewise. As we showed you, the visualization tools are there. The speed and the auto feature extraction is there. We're bringing the pipes, conduits, and the ducts right into Revit as Revit families. And we're not having to individually manually trace pipes inside of the Revit environment. So when you're doing large projects in particular, we're seeing significant time savings in modeling time by upwards of 75%. So we're finding we can just work much more efficiently in tools like Edgewise, and then just finish the models out in Revit, adding termination points and families.
All right, great. All right, and that brings us to the Ask the Experts, where we're going to obviously answer questions from the audience and learn a few more strategies and techniques for successful as-built MEP. And we have got the questions coming in, and Kevin Williams, if you'd like to take over to moderate the Q&A session. As I said, I do not have access to the dashboard for some reason right now on my screen. So if you want to go ahead and kick us off there, Kevin, with the Q&A. And
okay.
Audience, please continue to send in your questions.
Okay, no problem. The first question is for you, Mark Hanna. You mentioned about breaking your scans out into chunks. How into sections to model your overall project? How many scans per section? What are some good rules of thumb for breaking out your project into smaller sections?
Oh, that's a great question. We kind of attack that twofold. A lot of times before we even get to a site, we may, for instance, for sake of discussion, we might break a floor down, maybe a floor either in half, and we'll scan that one half of the floor, and then we'll scan the other half of the floor as a separate cluster. We tie all that together with our survey control network, where we're locating some targets with the total station, and then we move up to like the second floor, so on and so forth. That's where we found the most efficient, best results. We really have a lot of confidence that we're getting really good, tight registrations. We're trying to rely on the survey control network to help us do that.
Okay. Okay.
So
this I'm sorry, go ahead.
Just that to capstone that question, I don't know if there's a particular number of scans. It's really kind of hard to define that. We break it kind of more into the areas that we're working in.
Okay, that makes perfect sense. Here's a question in general for all of you guys, and one that comes up a lot. What are common accuracy statements that clients find useful? How do you express the accuracy in terms that your clients understand and are happy with?
I think some of that comes back to your initial report on your traverse data. I mean, you're only as good as your control traverse, so you can start from there, and then you can add the resolution of the scanner, I guess, kind of at that point. So, if a person were to give a general closure on their overall scan, and then add the accuracy of the individual of the scanner that you're utilizing, that's kind of it's kind of how we back up our data anyway.
Okay. Anybody else want to weigh in on that one?
Yeah, I think Mike's points are spot on there. With that, it really comes down to survey control. There's inherent inaccuracies in the scanner, so relying on a good survey control and adjustment techniques is really just going to make your scan data that much tighter and your registrations better.
Okay. What is your average setup time, and how many scans per day do you guys consider good productivity?
That's a loaded question.
How long is a string?
Yeah, a lot of that just depends on the environment. You know, is there going to be a lot of public presence around? Are you doing ceiling tiles? How high is the ceiling? You know, I mean, is it going to require a ladder, and you know, how much logistic operation is going around you as far as staff? You know, there's all kinds of, and then that goes back to your scanner. I mean, if you're running a TopCon or something, you can't expect it to be pushing out huge amounts of scan. And it also is kind of like depends on how far you're looking to collect data. I mean, if you're there's a big difference for us doing like a metro workstation and then a hospital. But overall, I guess, I don't know, we're probably getting about 20 to 40 scans with a particular scanner per day. But, you know, that's a 12-hour, 14-hour day also.
Yeah, if I could just expand on that, I think, again, Mike is spot on there. There's so many different factors that play into it. Furthermore, what you're scanning and determining your scanner settings are also really important. If you're scanning small, tight, confined areas, you can run the scanner at lower resolutions and more positions versus larger spaces where you can spread the scanner positions out. You might slow the scanner down to get more higher density scan results from positions spread apart from each other. And you know, I think maybe rules of thumbs are 20 to 40 a day. We've gone as high as 100, but again, you know, those are short duration, very close scans. So again, it comes down to what you're scanning and what your deliverable is.
I think it's interesting that you both said 20 to 40. I myself, we tell people 30. It's, you know, for phase-based is sort of the average that we'll expect to get a day, and it sounds like we're all saying the same thing. Obviously, you know, if you can turn your resolution down, you'll get more, but, you know, it better be very, you know, big stuff that you're trying to capture. So if you need small detail, then you got to crank it times. So yeah, I agree with all of them.
But it's about what we figure 10 to 15 minutes per setup. Is that what you guys are kind of thinking when you go and do your estimates?
We count 20. I mean, hopefully we go faster than that, but just to not stress the tech out with the instrument, we try to give them 20 minutes per setup.
We've got a couple of questions on scanning above ceiling tiles. This one specifically on tip number 11. Do you use targets above the ceiling tiles, or do you register from pipes, corners, and planes?
I can take this one. It's a pretty common question. The most difficult areas to scan. It really depends, again, on that ceiling plenum space. But for the most part, what we try to do is remove a few tiles within a particular area. We'll put targets kind of in the field of view within that space, or we'll put spheres on bipods, and then we try to get the scanner and kind of break the plane of the ceiling, and just try to maintain some of the at least 3 to 5 targets within that field of view on the lower side. And we sometimes, or most of the time, get really good results. There are occasions that we'll have to put targets up in the ceiling, and we'll just use spheres to do that. And as a last resort, if we don't collect, if spheres are either out of the field of view, we'll resort to using planes or cloud-to-cloud registration.
Yeah, I'm totally in agreement with Mr. Hanna on that. I think that's becoming more and more the way to go. Just because from a production standpoint, to get targets up from the top of the ceiling is almost counterproductive sometimes.
So another question right along those lines is how do you register scans measured from inside the ceiling plenum space? It seems like a tight fit that doesn't allow for positioning of targets.
Yeah, it kind of goes along that same premise. If you can't get a target up there, we'll rely on targets that we acquired inside of. For instance, we'll set targets in the lower half of the field of view. Sometimes that's all we have to work with, so we'll rely on those targets and usually use spheres down on bipods so that they can still see them when we have the scanner elevated up into the ceiling space.
I'd like to embellish on that too. If you are planning on doing the cloud-to-cloud registration, and that make sure that you pick something that is centristic to that room you're working in, and that you get enough definition, at least wall or ceiling corners adjacent to where the walls meet, and then have enough data down below where you have a good initial base scan for the cloud registration, and then perhaps hold that initial scan in the ceiling that's got the best fit geometry-wise and the best amount of data, and use that as a controlling element in your cloud registration for the plenum scans that follow in succession. And make it a lot denser than your other scans.
Okay. Mark, this question is for you specifically. When you're using a C10 and a Faro Focus to do the hospital, what software do you use to complete your registration with the 2 different scan data?
Well, we typically stay within the scanner software. So for the Faro, we're using Scene to do our registrations, and then for the C10, we'd use Cyclone. And that's fine, because oftentimes we're doing Revit deliverables, and we'll bring those data sets into, we'll do 2 things. We'll create PCG files, which we can now index from both those scanner manufacturers, and then we're only working with PCG files in Revit, and then similarly we're running those through Edgewise. So it really doesn't. So for us, we'll just stick with the registration tools
inherent to that specific scanner. And you can also, or we can also run them all in Cyclone too. We've done that as well.
So when there, do you end up with two separate registered clouds? How do you get the registration going between the two?
Comes down to survey control, running our survey control network, so that we register them on a common coordinate system.
Okay, that makes sense. All right. Let's see. We've already answered this one. Any tips regarding best practices for importing point cloud data into Revit as it pertains to the local survey coordinate system, which typically has large coordinate values?
We use a base coordinate, a base project point. In Revit, that allows you to match different drawings like your civil to the architectural to the MEP, as long as you have that common point amongst all of them. You got to kind of pick out the appropriate point to have that all interact together, but it should allow all those datums to exist on one truncated location. It gets a little bit weird when you have to involve the rotation aspect of it, but it is doable. I would suggest that you let them ponder that a little bit before committing to anything when you talk to your architect or your MEP guys on what the best point to do that with is. But it is doable, I think, in version 13 and above.
Okay.
Yeah, I would agree. I would echo those comments as well. And that's a pretty typical routine thing that we run up against.
Larry, you're Mr. Revit. Do you have anything to add to that?
No, he did a good job. He pretty much nailed it on the head. So I thought about adding, the fact that Revit only goes out a certain extent. So I believe the number is like 2 miles, and then you're going to have to break it into a separate project. But aside from that, I like the way Mike put it.
Thank you.
All right. How often do clients accept as a deliverable the Revit export from Edgewise as compared to a final Revit model with structural bits added?
Sorry, what was that one more time?
Sorry, let me repeat the question. How often do clients accept as a deliverable the Revit export from Edgewise as compared to a final Revit model with structural bits added?
We definitely have to embellish. We're not just handing over a feature extraction. For a large part, most of our clients want the full picture. So architectural, structural, MEP, all of it needs to be in there. We haven't had a client who just wanted the walls or just wanted the structure or just wanted, pipes. So, but I will say Edgewise definitely is a huge time saver. It's worth its weight in gold. So we've enjoyed using it, and it gives us a big leg up on getting all the piping done, and hopefully here soon a lot of the other elements.
Yeah, I'd like to make mention too that as far as Revit goes, there's always we do a fair amount of kind of underground parking work, and Kevin's got a great tool in there with the floor extraction tool in there that can be easily converted into a mesh, and you can't quite so much decimate it down, but it'll get things cleaned up to the point where you can run it through a second software application and drop that right into Revit, especially if those parking garages are non-conformal, where they have localized drain systems in it. It is kind of a very slick way to get that modeled and into Revit without spending a whole lot of time on it.
Here's another question for you guys. Do you ever use digital cameras to aid in overview of scanning projects? Do you guys have opinions on using digital cameras?
We take a lot of photographs as we're scanning. Now, I'm not sure if you're asking about just having an extra instrument on site taking photos, or actually putting a camera on the tripod. But one thing that others may or may not be doing is, we found running around with a digital camera while the scanner's running and just taking photos of the back sides of things, you know, in little areas that the scanner may not get to, just giving us a little extra information on top of the point cloud. It really helps us in the modeling process and helps us be familiar with the site when we go back to model.
No arguments there. The more pictures you have, the better off you're going to be, and the happier modeling people will be.
Here's another question. We're starting to run out of time here. Let me see. We understand that the point cloud should not be moved to ensure ClearEdge will populate piping elements in the correct position. What process do you take to coordinate a scanned model with a client's existing model?
Yeah, so there is a method for doing that, and I myself am quickly trying to open Revit so I can remember. It's manage coordinate system, and go under your manage tool, and in that same position area, you can help coordinate that. But yeah, you definitely don't want to move your point clouds. Hopefully, in most situations, you're the person who initiates it. I mean, you're creating the base file, and so you kind of want them to come to you, but and to stay with what you're doing. However, there is a situation where you know, if you're dealing with a large campus that has, you know, they're on a particular coordinate system, you want to start that back in the scan registration, and what's the word I'm looking for here, Mark? When you're setting control, so you want to set that before you even get into Revit.
Yeah,
does that make sense?
If I could expound on that a little bit, we just recently ran into a project under these circumstances. There was already an existing architectural BIM model, which was built on an assumed coordinates, which is the base point coordinate system in Revit. So we then had to add all the MEP and structure to that model. So what we chose to do was to create, using our total station, we went in and located common features on the building, and then we moved the point cloud to that same coordinate system as a model. This way, all the registrations and all the point clouds came in exactly where they were supposed to. So we basically geo-referenced to the client's model that they already had existing, and that worked out really well.
Yeah, if I'm not mistaken, I think there's a couple different settings on importing point clouds inside Revit. You can have, if you were to take and place one cloud that exists on the existing coordinate system, I forget what the terminology is on it off the top of my head, but I think it's origin on origin, and then the other one's in relationship to the last place cloud. So if you can get one of them in that data set positioned where you're happy with it, you should be able to use that truncation rotation value from that first cloud set in and propagate it into the rest of your imports for that data set. Do you guys agree with me on that? I'm pretty sure that exists inside Revit.
That works. That works when you're doing a group of them. However, what's weird is that position by the last one, as you get, it seems like 2 or 3 days worth of production in, and then you go back and try to place another one, it forgets where the last one was placed. Yeah, and won't be that option. And I don't know why that is. Hopefully 2014's fixed it, but so yeah, if you can set up that stuff before you even bring scans into Revit, set it up back in Senior Cyclone, you'll be happier when it comes to the Edgewise imports as well as any future point cloud imports.
Yeah, I agree with you on that. We've had to go back and have a secondary model, I guess now I think about it. And then, because you can only have one of those exist in any model. Once you change that, you do have that problem, but it can be done.
All right, I'm going to wrap up with one last question that I'm actually qualified to answer. This one is ClearEdge working with the new Autodesk Recap program? And Edgewise is actually a standalone. It has its own visualization engine, but we're really excited about all the stuff that Autodesk is building into their application. We're becoming, it's much more of a seamless workflow to go from Edgewise into Autodesk with the new visualization technology that they've incorporated. It works really quite well. Recap is a big step over their old PCG engine. So it's exciting to see Autodesk making those strides. That's the last question we have time for. I'm going to hand it right back to Kevin Corbley if you're still online.
Yes, I am. All right. Great. That was a great way to wrap it up, Kevin Williams. I appreciate it. And we are out of time. And on behalf of our panelists and our sponsors, Workflow 4.0 and ClearEdge 3D, let me thank you in the audience for joining us today. And a reminder, you'll be receiving an email after the broadcast with a link to the recording, as well as a chance to subscribe to our newsletter, Workflow 4.0. And there'll be other follow-up information about Edgewise MEP. And we hope to see you again later this summer. We'll be having another webinar then. And thank you for joining us.